number 3, Newton's second law of motion. Now, we have the Newton's second law of motion, the law of acceleration. Now, for the objective to investigate the relationship existing between force, mass, and acceleration. Number 2, to examine the acceleration is directly proportional to the force, assuming mass is kept constant. Number 3, to examine that the acceleration is inversely proportional to the mass, assuming force is kept constant. What are the apparatus? We have the weight. This one are the weight, or the weight hanger, tas plane with pulley, meter stick, dynamic cart, then the stopwatch, string, slatted weights. Now, for the procedure, letter A, constant mass with varying mass. Okay, set up the experiment as shown in the figure, this one. Okay, to counteract the friction, add the small mass of 10 grams to the hanger to allow the car to move with uniform speed. Do not remove the small mass in the next part of the procedure. Number 3, 10 grams. Place a 20-gram weight on a hanger. This mass will serve as the net force necessary to accelerate the object. Record the time it takes for the load weight hanger to drop through a distance. To convert a gram unit to dyne, multiply the given mass by 980 cm per second squared. This serves as the constant value of acceleration due to gravity. Then vary the accelerating force by adding the slatted mass to the hanger 120 grams at a time until all 3 20-gram pieces are loaded on the weight hanger. Then record the time it takes the hanger to drop. Do the same for every variation of the accelerating force, one at a time. Repeat the step for 3 trials. Take note that the car still serves at constant mass. Okay, for data and result, now constant mass versus varying force. We have the 10 grams here at the hanger. Then we have to put 20 grams for the first part for table 6.1. Okay, now, for first table, for table 6.1, we have to get for the mass. We have here the mass of 30 grams. Mass of 30 grams. To find for the force, you have to multiply the 30 grams into the gravity of 980 cm per second squared. Now, for the time, stop. 1.4 for the first trial. Start set. 1.02 for the second trial. Third trial set. 1 to go. 1.10. Okay, you have to solve for the average time and the acceleration. Now, for the mass, additional 20 grams. Therefore, we have 30 plus 20, that is 50 grams. Start, sir. 0.9. Go, sir. Okay, now for the third force, additional 20 grams. Now we have 70 grams for the mass. One, two, go, sir. 0.89 Now, for table 6.2, for the constant force but varying mass, to get the variation of acceleration, considering the mass placed a 20 gram in the hanger, this remaining load will serve as the constant accelerating force. Place a piece of 100 gram in the cart. 100 gram in the cart. Load are on the top of the cart. For every change in mass, record the time it takes the hanger to drop. This is good for 3 trials. Record the average time and the corresponding mass of the system. Remember that the accelerating force is constant and the mass increases every time a 100 gram load is added. Okay, for table 6.2, now the load for varying mass. Mass of 100 grams, mass of 200 grams, mass of 300 grams. Okay. Start set. 1.85. Okay, instead of 20 grams, we use 70 grams for number 2. For the mass in the hanger. Okay. 1, 2, go set. Additional 200 grams. Now, for the second force, added load, we have 200 grams. Start set. 0.75. Start set. 1.36. Now, another 100 grams for the cart. Okay, 1.27. 0.78. Closer. 0.9. Closer. 0.7.